Hello? Can you hold, please?
Shalom and welcome everyone. I want to welcome you once again to Checkpoint Training Bytes. Checkpoint Training Bytes is where we bring you advanced training on Checkpoint products, features, and blades. In this training module, we'll be looking at Checkpoint VPNs. Checkpoint offers two kinds of VPNs. We offer the IPsec VPN and also the SSL VPN. In this training module, we'll be discussing both of these VPN technologies. And we're going to break down these technologies and discuss the key advantages between them. And this will help us give a better understanding of how they work. Before we get started, let's take a look at the agenda of this training module. We will start this lecture by first discussing the need for security. We will start right from the beginning of the internet development. What were some of the challenges to keep the data secure over the internet, and also discuss some of the pre-internet VPN solutions. Next, we're going to discuss the motivations for using VPNs over the internet, why VPNs were introduced to keep data secure and private, also at the same time keep operational costs low. Then we will discuss some different types of VPN solutions, how IPsec and SSL have become the leading industry standards. Here, we will next discuss how and why Checkpoint became involved in VPN solutions. We will discuss the difference between Checkpoint VPN products and when and why they were introduced. Next, we will discuss different VPN topologies. What are the main differences between a site-to-site VPN and a remote access VPN? When should you use either one or both of these VPN topologies? Finally, we will discuss not only why Checkpoint offers two different VPN solutions, IPsec VPN Blade and a mobile access VPN Blade, but also why Checkpoint supports two different protocols. What is the difference between IPsec protocol and SSL protocol? And what protocols work with each of Checkpoint's VPN solutions? So let's start our discussion from the beginning. When the internet and the World Wide Web was just starting to converge together, it was a very humble beginning, but it was a very honorable creation. And as the internet started developing and expanding, it was at first mostly used with virtuous motives. Most traffic was passing in the clear, exposed, and unprotected. But at that time, there really was no concerns. Everything was rosy. Most reasons to use the internet was righteous and noble. It was used mostly for various methods of communication using very simplistic protocols. But as the internet grew larger, there started to be nefarious interests on the internet, lurking and observing, either to cause damage or interrupt the daily workflow. After all, it was a public infrastructure, and their motives were not always honest and admirable. And even today, the internet can be used for good or for evil. And so companies needed ways to protect their data, to be sure that the data was confidential, that no one can access it, making sure that the data was private and secure. They also needed to be sure that the integrity of the data was intact, meaning that no one had modified the data and the data was original with no changes or unauthorized modifications. And in addition, they needed to be sure that authenticity was verified, meaning that they were communicating to the original intended author and recipient. In other words, it was not an imposter or a phony pretending to be someone else. This is also called the CIA model. Confidential, integrity, authenticity. Sometimes the A could be for authentication. Sometimes you'll see CIA 2. But for this discussion, I will use authenticity. We will refer to this model again in this video. One of the original and primary solutions to guarantee all these conditions was to use a dedicated private line, a private lease line, which was used to bypass the wilderness of the internet. But these dedicated lease lines were very expensive. Companies had to rent or purchase dedicated equipment. Basically, they owned or rented the equipment and made their own private lease lines. This would definitely make sure that data was protected, since this equipment was dedicated to only one specific customer, and so the resources were usually not shared with other customers. But this solution was very expensive, which meant that regardless if you're using the equipment or not, you were still being charged to reserve and hold the equipment for when you needed it. Another way to look at this is to think of it as a long-distance telephone line. This line was dedicated to customers, and customers were paying for long-distance service charges every month, regardless if they're using it or not. Regardless of how much data was being transmitted, if you don't need it in 1 month, You're still paying the long-distance telephone calls just to rent the equipment for the instances and occasions that when you do need it. In comparison, contrast this to using the internet, which is very cheap to use because it uses and shares its equipment and time to distribute the load and resources amongst thousands of users. And so in order to combat this expense of private lease lines, some companies started to offer many secured solutions, like VPNs, a virtual private network, which really means that you're using a public infrastructure like the internet and creating your own, in quotes, private dedicated leased line, close quotes. This is what we call a VPN, a virtual private network. How? By first, confidentiality. By first encrypting the data to be sure that it cannot be seen, to make sure it stays private. By message digesting each packet to be sure that the packet was not tampered with. And signing each packet with a digital signature to be sure it was truly from the legitimate sender and received by the right person. And so by using the VPN solution, you can use a cheap public internet infrastructure and bypass the astronomical expense of using a private lease lines and still keep your data secure and private. Now let's talk about different ways that organizations might choose to set up VPNs. There are many kinds of ways to build VPNs, and there are many vendors offer competing solutions using different protocols that can help build VPNs. Solutions like PPTP, L2TP, GRE, SSH, SSL, IPsec, and others. Most vendors offer one or more of these solutions. In this video, we'll focus primarily on two methods, IPsec VPN and SSL VPN. These two solutions are probably the most popular and have become an industry standard, with a wide range of solutions with improvements and continued development by many vendors and manufacturers. There are really two different frames of thought. Most vendors are in SSL is the best camp. Other vendors say that IPsec VPN is the best. And so each vendor will support either one of these two VPN solutions. Not so with Checkpoint. We offer both solutions because there are some pros and cons between both of these two VPN competing methods. There might be specific reasons why you want to use either one of these methods, and hopefully this video will help shed some light on this. Today, the differences between them might be almost indistinguishable, at least from the user's perspective. But from the architecture or administrator's perspective, there are some major differences that we'll discuss in a moment. But before diving into the pros and cons, let's take a step back in time again to see how and when and why Checkpoint now offers two competing VPN solutions. Even though Checkpoint now supports and sells both VPN solutions, traditionally that was not always the case. First, let's take a look at IPsec VPN. IPsec VPN was one of the original core products. After Checkpoint invented the stateful inspection firewall in 1993, it then introduced IPsec VPNs into the product line around 1998. And so for a long time, Checkpoint used to offer only IPsec VPN. I believe they were in a camp that IPsec offers the best security, with the most reliability with regards to data confidentiality and data integrity. And only many years later, around 2003-2004, did they introduce an SSL-based appliance. They first came out with a new product called the Connector, which is an SSL-based appliance. The Connector appliance was a dedicated appliance that offered only SSL VPN capabilities. It ran on the Linux operating system, the Splat. And so regardless of which camp you belong to, no problem. We now offer both VPN solutions. And so for a while, Checkpoint offered two different appliances. Their traditional firewall with IPsec VPN capabilities, and now a new SSL appliance, the Connector appliance, which is really only a dedicated SSL appliance. And then a few years later, the Connector product line became integrated into the Checkpoint full firewall product line. Meaning that today, we only sell one appliance, our traditional firewall appliance, and then you can enable either the IPsec VPN or the SSL VPN product, or both. Either one or both can be enabled and run on the same gateway appliance. When we first integrated the Connector appliance, we called it the SSL VPN Blade, which makes sense since it does SSL VPNs. But now with the popularity of smartphones and tablets, in 2009, the SSL product got renamed to Mobile Access Blade, or MAB for short. But even if you know a little bit of the history, it still does not explain the why. Why does Checkpoint offer both methods? First, let's start off with a few reasons that a company or organization might need to configure VPNs. One reason is that when a company starts growing and expanding into different geographical locations, it might still need to access the resources in the corporate or branch networks. A company might have multiple offices in various locations and sites, and in order to correspond across vast distances, they will send the data over the internet, and they will need to guarantee that the data will be kept secure and untampered. This is what is commonly referred to as an intranet. An intranet is a private network that a company uses to exchange information securely over the internet. Another reason to use a VPN is not only to use a company's resources that are located in remote locations, but it also might be needed to access and share information with distant vendors or partners, maybe suppliers or distributors or authorized customers. This is what is referred to as an extranet. An extranet is a network which enables authorized business partners to exchange data securely. But all of these scenarios is what we refer to a site-to-site VPN, or a network-to-network VPN. I've also heard it being called a gateway-to-gateway VPN or a router-to-router VPN, because all of the traffic is encrypted between the gateways, between the routers. The traffic from the desktop to the gateway is in the clear, meaning it's not tampered. From the server to the gateway, it's also in the clear, unencrypted. Only the traffic that is exchanged between the gateways are actually being encrypted, using ciphers encryption algorithms. How this works is when a desktop or PC wants to communicate to a remote server or needs access to records or data that are stored in protected remote locations. From the desktop's perspective, it believes the server is in the local network. So the packet is sent in the clear, and then the packet gets routed internally to the gateway, which is the VPN networking device. And when the gateway recognizes that the destination IP is part of a remote encryption protected network, and so the local VPN gateway will negotiate a VPN tunnel between him and the remote VPN gateway. They will exchange keys encryption methods in order to establish a secure VPN tunnel between themselves, between the sites, between the gateways. And then all the traffic that exchanged between the sites will be encrypted using the keys and algorithms that were used and negotiated during the negotiation phase. And so all the data between the client and the local gateway are in the clear, but the local gateway to the remote gateway, all the data will be encrypted using the VPN encryption schemes agreed upon during the VPN negotiation. Then the remote gateway will then decrypt the packet and send it to the server in the clear. And this process is repeated in reverse direction. The server will reply back to the client in the clear. The packet is routed to the remote gateway. The remote gateway recognizes that it needs to encrypt the data. The data is encrypted. The packet is then routed through the internet, encrypted and protected. And when it receives or arrives on the local gateway, it is then decrypted. And this process is repeated for every and all packets that are being exchanged between the client and the server. And so this is what we refer to as a VPN tunnel. Not a tunnel in the literal sense, but a tunnel in a virtual sense. The packets on the internet can take different routes to get to a final destination. So it's not a physical tunnel per se, but it's a virtual tunnel. And this virtual tunnel refers to the fact that no one on the internet are able to decipher the packets, decrypt the communication, because all of it is encrypted. These cipher packets can only be decrypted by the participating gateways, what we call the peers. The cipher keys that are used to decrypt the packets are the same keys that were negotiated in a tunnel establishment phase. So the traffic inside the organization is always sent in the clear, meaning unencrypted. But this is fine since we trust the original sources, since we trust the sources inside the company's infrastructure. Only the traffic that's sent through the internet that needs to be protected is encrypted. And so this tunnel between the gateways is what we refer to as a virtual tunnel, the VPN. Another major reason to have VPNs is if a company have a big, wide roaming user base. For example, an organization might have a traveling sales force. The sales force might need to have access to the company records when they're remote. Or they might have remote users or users that are working from home. And so these remote users need to access the data and resources that are stored on the corporate or branch offices. And this again is where the VPN comes in. data needs to be secured over the internet, which is the public domain. So we need to be sure that the data is protected and secured and untampered when it travels over the internet. This is what we call the client-side VPN, also known as a remote access VPN. Today, this is a very fast-growing field. Remote users might need to access corporate resources from different locations using either their desktops, laptops, or maybe they need to access the company's resources from their smartphones and tablets. And so all of these devices might need to gain access to the corporate organization's resources. And with malware and crooks on the rise, it is important to make sure that remote users and corporate data is always protected at all times. And so just to be sure this is clear, when a remote user needs to access resources like records or data that are stored in the corporate or branch networks, the remote access VPN software that's running on the client desktop PC, the software will recognize that the destination network is part of a remote VPN encryption network. And so then the client, the VPN agent, will start to negotiate with the remote gateway to build a VPN tunnel. Just like a site-to-site VPN. It negotiates things like what encryption schemes to use, what encryption methods to utilize, and when the tunnel negotiation is completed, then the client can send and receive data to and from the gateway, all being encrypted. And all the data is encrypted from the remote access device directly to the gateway. The gateway decrypts it and sends it on to the remote servers, the internal servers, the protected servers. And this communication from the remote gateway to the servers are always in the clear, unencrypted. And then when the remote servers replies again, it replies in the clear. A packet gets routed to the remote gateway. The remote gateway then starts the encryption phase all over again, encrypts the packet, sends the packet through the VPN tunnel, through the internet, and traffic is always going to be tunneled between the remote gateway and the local gateway. And so now that we know the reasons to use VPNs, let's get back to Checkpoint VPNs. So Checkpoint today offers two VPN products. We have the original IPSec VPN blade and now the new Mobile Access blade. Remember, the Mobile Access is a rebranding of the original SSL VPN, which came from the connector product line. The IPSec VPN blade can support both site-to-site or client-to-site VPNs. A Mobile Access blade is only a client-to-site VPN. It can only do remote access. It cannot be used to set up a site-to-site VPN. In other words, a site-to-site only supports IPSec protocols. A client-to-site supports both IPSec protocols and SSL protocols. And so not only does Checkpoint offers two different VPN solutions, IPSec VPN products and the Mobile Access product, each VPN solution can support different encryption protocols. A VPN tunnel can be established and encrypted using either the IPSec protocols or the SSL protocol. Traditionally, the IPSec VPN used the IPSec protocols. The Mobile Access blade uses the SSL protocols. This is no longer the case. The IPSec VPN blade can work with either both IPSec protocols or the SSL protocols. On the other hand, the Mobile Access blade only works with SSL protocols. And so the main difference between IPSec VPN blade and the Mobile Access VPN blade is this. And I think the first question to ask is, do you want to set up site-to-site VPNs or client-to-site VPNs? If you want to set up site-to-site VPNs, then you can only use the IPSec VPN blade. The Mobile Access blade does not do site-to-site VPNs. On the other hand, if you want to do client-to-site VPNs, then you can use either blade. A client-to-site can be established with either the IPSec VPN blade or the Mobile Access VPN blade. And so to answer the first question, what product to use, IPSec VPN blade or Mobile Access VPN blade? If you need a site-to-site, then you must use IPSec VPNs. But on the other hand, if you need a client-to-site VPNs, you have your choice. You can use either product. You can use the IPSec VPN or the Mobile Access VPN. And so since site-to-site VPNs, you can only use IPSec VPN blades, and since this video is really about the differences between IPSec protocols and SSL protocols, we will no longer discuss site-to-site VPNs. We will continue to focus only on client-to-sites, remote access VPNs, which can use either IPSec VPN protocols or SSL protocols, or use the IPSec VPN blade or the Mobile Access blade. And so if you need site-to-site VPNs, you don't need to continue watching this video any longer. On the other hand, if you do need client-to-site VPNs, then we're right back to the first question, which is, do you want to use IPSec VPN product or Mobile Access product? since they both can do remote access VPNs? So the answer here is a little bit more complex. A sub-question would be, do you want to use IPsec protocols or SSL protocols? If you want to use the IPsec protocols, then you can only use the IPsec VPN blade. Because the mobile access blade does not support IPsec protocols, mobile access blade only supports SSL protocols. If you want to use SSL protocols, then you can use either the IPsec VPN blade or the mobile access VPN blade. Both of the blades will support SSL protocols. But even though they both support SSL protocols, there are different implementations of how they support SSL protocols. We will see that later on in this video. So then the real question is, what protocols do you want to use? And this comes to the heart of this video, which is what is the difference between IPsec protocols and SSL protocols? What are some of the advantages of using IPsec? What are the advantages of using SSL? Which boils down to, what product do you want to purchase? Do you want to purchase IPsec VPN or do you want to purchase SSL mobile access blade? And so now, before finishing this video, let's take a few moments to summarize all the information that we covered in this module. First, we started off this lecture by discussing the start of the internet. How security was not even a consideration at the beginning of the internet's foundation. But later, it became a concern as the internet grew larger and with various players with different motivations, some of which were not always honest or admirable, which this in turn caused organizations and companies to find ways to secure their data. A popular solution at the turn of the century was to purchase a private lease line. We discussed how a private lease line was introduced and created to secure traffic amongst organizations, local networks, and remote networks infrastructures, and how a private lease line offered security protections like the CIA, confidentiality, integrity, and authenticity. But a private lease line was very expensive, which in turn helped motivate the start of the VPN security industry. Also, we discussed how the VPN industry originated, how different VPN protocols were introduced and used to keep data secure over the internet, and how two primary protocols like the IPsec protocols and SSL protocols grew to become the industry's leading standards of today. Then we discussed the differences between IPsec blade and mobile access blade. And here we discussed how Check Point first introduced the IPsec VPN blade around 1998, which supported IPsec protocols, and then later we added the SSL protocol support to the IPsec VPN blade to help address some of the challenges and limitations with the IPsec protocols. And then later in 2003, we introduced a new SSL VPN appliance, the Connector appliance, which later merged into the mobile access blade, and how today Check Point offers two different VPN solutions, the IPsec VPN blade and also the mobile access VPN blade. And in our effort to explain why we offer two different VPN solutions, we discussed two different kinds of VPN topologies. We discussed what a site-to-site VPN is, and how an intranet can be used to secure an organization's traffic between the corporate head office and also amongst its various remote branch offices. And then we discussed what an extranet was, which is a VPN that secures traffic between a corporation and its various partners, resellers, vendors, and customers. Then we discussed remote access VPNs, which are client-to-site VPNs that secures network traffic that's transversing over the internet from roaming users so they can access the corporation or branch records or data from the remote locations, either from home, hotels, or cafes. Finally, we discussed not only why Check Point offers two different VPN solutions, IPsec VPN blade and mobile access VPN blade, but also why Check Point supports two different protocols, the difference between IPsec protocol and SSL protocol. And we also discussed which protocols work with each of Check Point's VPN blades.
I hope you found this video informative. I hope to see you in the next video. Until then, shalom and bye for now.
Check Point. We secure the future.